All right. So number 9, guys, I would pay attention, okay? I'm going to do one of each of the hardest types. Anytime you have addition or subtraction, that's what makes it harder because you have to find a common denominator, okay? So what you do is if you can factor anything, you would factor it. There's nothing to factor here, okay? So what we do is we say, okay, what would I need to have in my new denominator for these to be the same? So I know I'm going to be creating 2 new denominators. What they would be is, remember, anything that's represented in both of the denominators has to be in our common denominator. So this would just be 3x squared x plus 5, 3x squared x plus 5. That's my common denominator, okay? Then, so what I'm basically saying I'm doing here, guys, is I'm changing this green fraction to this purple fraction. So I'm going from a denominator of just 3x squared to a denominator of 3x squared times x plus 5. So I have to multiply my denominator by x plus 5 to get this denominator, right? That's what I would have to multiply by. So whatever I do to my denominator, I have to do to my numerator. And then I'm going to distribute. So that would be 2x plus 10. In my second fraction, I have an x plus 5 in the denominator, and I'm wanting to change it to x plus 5 times 3x squared. So I'm missing the 3x squared here, right? Multiplying that by 3x squared. Fine, now it matches that, but don't forget if I do it to the denominator, I have to do it to the numerator. And don't forget that that's a negative there. So when I distribute that, this becomes a positive, and this would just be negative 21x squared. Then we would put it all together. And as we know, sometimes the program that makes this puts them in different formats. Like I would put the 21x squared first, the negative, in standard form. I've always been telling you standard form is best. It still is. I'm not really happy about how this program just puts it like in order like that, but it's not wrong, okay? Either if you had your answer like this or the way I'm writing it, either way is fine. What's important is that the 2x is positive, the 10 is positive, and the 21x squared is negative. That's what matters, no matter what order you have it in, okay? Over 3x squared x plus 5. Okay? So that's the adding and subtracting ones. They're tricky, all right? And so that's 11 and 12 as well. 9, 10, 11, 12. So I'm going to leave those for you to work on, and I will help more and do more with you guys tomorrow, the day before the test. Listen, this is not a test you want to blow off, okay? There's too much on here that you could lose points on. We've got to know how to do these problems. I'm giving you 3 days, right? What do you say? Thursday's the day. Mm-hmm. All right, guys, we've been doing this for like over a week. This was our most recent, these two down here were our most recent open note quiz, okay? Before we did those, though, we did something called reciprocal functions, rational functions. The difference, look at them, look. The numerators here are just a single number, 1, 4, -7, something. Whereas rational, there's x's, okay? These are a little easier. All we need to worry about here is a VA and an HA, and it comes from that denominator. Remember, VA is always x equals, and set it equal to 0 and solve, you get 1. Right here is where this is a little different than anything else. It was y equals whatever this number is. You don't change the sign. Be careful. Okay, so I'm not going to graph this one, but let's just pull out the VA and the HA just to make sure you understand it. It's always going to be x equals and y equals. Don't forget that. That's hay. Our vertical asymptote would be x equals 2. We find the 0, which means set it equal to 0 and solve, In the horizontal asymptote, we just take the number, okay? Because it's not attached to a letter. It's like already in its zero form, so to speak. All right, so let's just go back to this one and graph it. Vertical asymptote at x equals 1. Horizontal asymptote at y equals -1. We make a table of values and we pick two numbers. We pick a number to the left and a number to the right. Doesn't matter which one we do first, and it's always on the left and right of our vertical asymptote, which is the same thing we did on the ones down here. You'll see again in a minute. So if we're at x equals 1, to the left of it would be 0, to the right of it would be 2, right? 1 is right in between those two numbers. And I'm just going to plug in 0 for x and then 2 for x, and whatever I get gives me my y, and that's going to give me where my branches are. So I plug a 0 in there, 1 over 0 minus 1 minus 1. So 0 minus 1 is -1, and you can do this in your calculator. 1 over -1 is -1, and -1 minus 1 is -2. So we have a point at 0, -2. That shows me I have a branch right there. Remember, those asymptotes kind of make a new quadrant. Keeps your branch arms within that, the dotted area. Okay, plug 2 in. See, what this is going to do is tell us if our branch is in this quadrant or down here, depending on what we get. So 1 over 2 minus 1 minus 1. So I just plugged a 2 in right there. 2 minus 1 is 1. 1 divided by 1 is 1. And 1 minus 1 is 0. So we have a point at 2, 0. So I now know the rest of my points would be in here somewhere. But we don't need a table of values for all those points. Just getting that one point is good enough. Okay? Recognize this type of problem is where you have just a single number in your numerator. Okay? You always do those the same way. Well, this is where the most points come from, Dylan. So, all right? 16 is harder than 15, so let me do 16 instead. Notice these are a little different. They're still like fractions with letters and stuff, but these have letters in the numerator, whereas 13 and 14 didn't. These are the ones that you have to find a whole bunch of information. You have to find the wholes, the VA, 0, and the order of these doesn't matter, but I'll put some blanks on it, just like I did for your quiz. And on these, you want to factor the denominator only. That's all we care about is our denominator. And actually, no, we factor both. I don't know what I was thinking. Factor both. So factor anything we factor. My numerator has a GCF of x. And what's left goes in the parentheses, GCF. Same thing on the bottom, has a GCF of 3x. And in this problem, we have, well, first thing you always look for is whole. And that's why I always put it first to help remember you, to help remember you. Does anything cancel in this? Look closely. Does anything cancel? Nothing cancels. Are you saying that's the case? That's wrong. X's cancel. See how these X's are not attached to pluses or minuses? That means we can cancel them. You can't cancel like, you wouldn't be able to cancel like x over x plus 3. You wouldn't be able to cancel anything there. But like 4x squared over x, since they're not attached to any pluses or minuses, you could cancel one of those for that. All right, so that means you have a whole at what? 0. If you set x equal to 0 and solve it, well, it's already solved. You're going to have a whole at 0. Okay? So that's all that canceled. Do we have a vertical asymptote? It's the x left in your denominator. Just same way you found this one. You set that equal to 0 and solved it. You got x equals 1. This would be x equals 3. This 3 here is not attached to an x anymore, so it's just a number here. You don't get anything. That 3 doesn't do anything over here, okay? And we have a 0 at negative 3. That's my numerator. Anything left in the numerator is a x-intercept. And remember, HA is probably the hardest part, okay? Let's review that really quick. We're looking at, I'm going to give you a quick lesson on this again. Degree of your numerator versus the degree of your denominator, okay? So if m is greater than n, you have no horizontal asymptote. If m is less than n, your HA is y equals 0. And if they are equal to each other, your HA, horizontal asymptote, is whatever the leading coefficients are. Simplify it if you can, okay? So before I scrabbled all in there, we had, is that x, oh, they're both 2's, right? X a second, 3x a second, I can't see. Yeah, so in this case, m equals n. The numerator equals the denominator. So our horizontal asymptote is going to be a is 1, b is 3, 1/3. Okay, there's a 1 in front of this one and a 3 in front. That's your A value and your B value, so it's 1/3. Okay, lots going on there. Whole is the last thing we graph. Last, okay? Vertical asymptote at x equals 3. Horizontal asymptote, that's 1/3. That's tiny. Just do the best you can. Bless you. Remember what a 0 is. It's an x-intercept. So we go over to the, on the x-axis, over to negative 3. Right there. Whenever we have a 0, we're happy, because that gives us one of our branches. Now we're only missing the one to the right of our vertical asymptote. Just like the ones above it, you're always going to have a branch to the left and to the right of your vertical asymptote. When you have a 0, that gives you one of your branches. If you had none, well, then you'd have 2 numbers in your XY chart. You have to pick a number to the left, pick a number to the right. We don't have to pick one to the left in this one. We just have to pick a number to the right of x equals 3, which would be 4. And that will tell us where our second branch is. So I'm going to plug back into the original equation and then use my calculator to simplify it. A lot of math going on in this one. Here. So that's 16 plus 12, right? 4 squared is 16. 16 times 3, I think, is 48. Minus 36. And then more calculator work. 16 plus 12 is 28. 48 minus 36 is 12. And 40, did I do that math right? No, that's 16 plus 12, 6, 7, 8, yes. 16 times 3, yeah, 48 minus 9 times 4, 48 minus 36 is 12. All right, 28 divided by 12, math, enter, enter, yuck. This point would be at 7/3. How would I know where 7/3 is? It's also a decimal of 2.3. Okay, so you could use 2.3. I mean, that's what my calculator gave me is 2.3. For exponents first, 4 squared is 16, and then 16 times 3. Do you see that, Evan? Okay. So where's 2.3? Yuck. Go to the right 4 and up somewhere between 2 and 3, right? 2 and a little bit more is what that means. So the right 4 up 2 and a little bit more, and now you can see where your branch is. Don't forget the hole. Go back to the graph and look. Here's 0. X is 0 right here. Where does my graph touch 0? Right here. That's where my hole would be. And these are tiny graphs and curvy, so if it's in the general area, that's fine. Okay? So I'm going to put the key back up for the ones that we didn't do together. You did it yesterday? Yeah, I missed it.